Okay, so that day we talked about gold leaf electroscope, and the figure is here, and I told you that this is a glass, like this is a closed box. The windows, these are the glass windows, and there is an insulator, like uh, insulating cork kind of rubber, this the cap of this hole, like there is a hole in this top of this, the top face of this uh, box, and through which you can insert a conducting rod, and this top there is a knob, this is called metallic knob, and at the end of this metal rod there are gold leads. Okay, and we have seen the the effect. What we see here is called uh, electrification by or charging by conduction. What is that? Charging by conduction. So today we'll see what is charging by conduction and what is charging by induction. Those things we'll be learning. Okay, so first part is charging by conduction. Look, conduction means there will be uh, touch, bodily touch. I think, yeah, my screen is still coming. uh, just a minute. It is actually taking little time to change the screen. Now I am showing you my presentation, but it has not yet come. uh, so conduction means when you have, suppose, a charged body and a neutral body, and when you touch a charged body to a neutral body, then the charged body will be transferring some charge to the neutral body, and that also will be charged. I don't know why the screen is okay. I'll just reset the screen. There is some issue with the screen. Okay, look, Nikhil also has left now. I don't know, maybe internet issue is severe for him and Pritika. I'm just waiting for my screen to come here. Are you able to see my screen, Priyadarshini? Are you able to see?
Yes, sir.
Now, are you able to see my screen? Okay, what you
Yes,
see?
sir. I'm able
The
to
book
see, sir.
itself, or you? No, are
Charging by
you seeing my
conduction.
presentation, or you are seeing the book presentation, right?
Yes, sir.
Okay. So then, yeah. So if you are able to see my presentation, then it's very good. So conduction, charging by conduction, we will be discussing now. So, so suppose there are two, like identical metal sphere. One is neutral, another one is having some 6 charges. You can see positively charged uh, sphere. These two are identical sphere actually, and these spheres are mounted with insulating stands. Now see what we do. This is the first position. I just kept. I have just taken two identical sphere. One is neutral. Another one is having positive charge charges, and or I can say this is positively charged, and they are actually mounted. They have been mounted with two insulating stands, and now if you bring them in touch, so conduction means you have to bring in contact. Okay, then only, see, the neutral body and the charged body, they will share the total charge equally, so the charge will be distributed equally. What will happen? The charge will be distributed equally. Okay, and so in contact, when the neutral body comes in contact with the charged body or the charged sphere, both the spheres will be this sharing the total charge. Okay, so both the spheres will be now positively charged, but the charge amount of the charge will be half if we just separate them out. What will you see if you are separating them out? Then you will see the neutral body, neutral sphere which had taken initially, that also will be getting some three positive charges, and the sphere which was earlier having six positive charges, it has also three positive charges. That means this happened. This is actually called charging by conduction. So in the process of conduction, you take a charged body and bring that charged body in contact with the neutral body. Then what will happen? The charge will be shared by both, and if you separate them out, then you will see the neutral body is no longer neutral, it has also got some charges. Now if I give you uh, simple homework or simple problem, suppose this body had some, so I have three spheres, suppose identical spheres. So this is A, this is B, and this is C. So it has, suppose, positive 6 charges. This is neutral. Okay, this has zero charge, neutral. B is neutral, and this has minus uh, 4 charges. Okay, minus 4 charges. Okay, then now see, I bring A and B in contact first. So what you see? What you see? A, B in contact. Then A will get
A
positive
has
3
3 and
positive
B has
charges. Right. B also will be having 3. Now if you bring this A or B, suppose B and C I bring in contact, so what you will see in this case? B, C in contact. If you bring B and C in contact, what you see? So B has now plus 3 charge and C has negative charges, right? So see, they will be actually, see, one has positive charge, so the net charge will be how much? Net charge will be -1, and that will be shared by both, right? So that will be minus zero
minus.
point 0.5. So both will be having minus zero point 0.5, minus point. Yeah, minus zero point 0.5 and minus zero point 0.5. Both will be having minus zero point 0.5, minus zero point 0.5. Hello, Nikhil. See, I have discussed on good, on important topics here. So charging by conduction. So in this process, what we do, we take one neutral sphere, identical. See, these two spheres are metallic spheres or conducting spheres, and they are identical in nature, but one is positively charged, another one is neutral. So here charge is 0. Now if you bring them in contact, the total charge will be shared between these two. So one will get positive 3 charges, another one will get positive 3 charge. So if you now separate them out, so how much charges they will get each? So neutral, the sphere which was neutral in the beginning, that will get positive 3 charge, and uh, the the one which has 6 positive charges, that also will have 3 positive charges. Now that means the charges will be shared among them equally. Now I have given one example here, that if I have 3 spheres A, B and C, and if I have A positive 6 charge and B is neutral and C has minus 4 charges, then if I bring A, B contact and separate them out, what will be the charges on A and B? So see, this was neutral, B is neutral, I am bringing these two guys in contact, so the charges will be equally shared, and if we separate them out, one will be positive. So A will be positive 3 and this also will be positive 3. Okay, so 3 plus 3 plus they will have. Now what happens if I bring B and C in contact? So what happens? B and C has already minus 4 charge and B has positive 3 charge. So net charge will be minus 1 and this minus 1 charge will be shared among both of them equally. So finally, what is the charge between B, like what will be the charge for B and what will be the charge for C? Both will be point 5 minus point 5. Okay,
Sir,
so this
how
is
is
the
the
situation.
charge minus one?
Sorry, sorry.
How is the net charge minus one,
How is the
sir?
mark? Okay, right. So this has positive 3. This is B and C has negative 4. So what will happen? Positive and negative, they will make them neutral. The 3 positives are there and 4 negatives are there. So 3 positives and 3 negative, they will make 3 negative. They will actually combine each other and they will make each other neutral. They will cancel each other. Okay? Cancel each other. They will cancel each other. Understand? Do you understand now?
Yes,
Positive and
sir.
negative, they will be, yeah. So that's how it will be. Net charge will be minus 1. Okay, so this is by conduction, charging by conduction. Actually this effect has been used, this charging by conduction has been used in case of gold leaf electroscope. electroscope so here this process has been used. Even induction also can be used. See what happens. See, this is a conducting rod, you can say, the conductor. So these are the gold leaves. So initially when they were neutral, they were very much close to each other. They were close to each other. Okay, like this. They were close to each other. Here, see. This is the initial situation when there was no charge over here. Okay. So they were initially very close to each other. See, the distance between them is very less when both the gold leaves are neutral. Now when you bring a positively charged body and touch it here, so all the charges, see, so this by conduction what will happen? See, these gold leaves also will be charged positively. How? See, the electrons from gold leaves will be attracted by this positively charged rod. Okay, positively charged rod. And so here what will be happening? You will see lack of electrons here. That means majority of the charges will be positive charges over here. That's why, so both the gold leaf, because both are in contact with this rod itself, so both of them will be positively charged. So when they are both positively charged, and we'll be very soon learning that uh, according to Coulomb's law, or in the previous examples also, when we have seen that with far, if you just rub ebonite with far, okay, with far, then this ebonite gets negative charges. Okay, ebonite gets negative charges, and that ebonite can repel other ebonite rod. That means like charges are repelling each other. So in this case, if the gold lips are both positively charged, they will be repelling each other. And similar things will happen if you bring a negatively charged rod. So then also you'll see the due to the repulsion, they will diverge or they will go away from each other. See, the distance between them is very large in this case compared to the neutral case. So this is how we can understand the presence of charge. Now you might be thinking, sir, you told that electroscope can detect the polarity also. Not only the presence of charge, it can even detect the polarity also. So how is it possible? How is it possible? So it is possible to detect, like, see, if suppose, uh, okay, so I'll just draw it here somewhere. Okay, so suppose I have this electroscope, already charged electroscope. Okay, charged electroscope, positively charged electroscope. Okay, that means these gold leaves are having positively charged, like positive charges. Okay, this rod as well, and this also will be having positive charge. Understand? Now if I bring another positively charged rod, then if I bring another positively charged rod, then what you see? So what you can
Repulsion
see is,
metal bob, sir.
yeah, can you tell me what will happen? Yeah, Priyadarshini, you wanted to say something. Yeah, tell me what you will see if the,
Repulsion between the metallic
yeah,
bob and the charged conductors.
metallic bob and the and the rod, this one. Now what will happen to this one? Suppose it is already there is, see, divergence. Okay, or they repelled each other already. But now what will happen to this gold lip if I bring another positively charged rod over here? Can you tell me what will happen? Okay, I'll tell you what will happen. See, uh, so in this rod you have positive charges, right? So what will happen if you just bring it here and just keep in contact? See, here actually in the gold lip, see, some positive charges, there are excess positive charges. That doesn't mean that there is no negative charges at all. So there may be neutral atoms and some positive atoms, like that. Positive charges, some are neutral. Those are there. So in the neutral, what will be there? Both positive and negative will be there, right? Both positive and negative will be there in the neutral atoms here. Now when you bring another positive rod over here, I'll just draw again, maybe, yeah, little more clarity. With little more clarity, I'll just draw. See, they are already positively charged. This one, this gold lip. So that's why they are diverged from each other, or repelling each other. Now you bring another rod which is already positively charged here. So what happens actually, see, in the gold, as I was telling you, in the gold, there are excess of positive charges, but there are neutral atoms also here, neutral atoms. So which has both positive and negative charges, positive and negative charges. That's why they are actually the positive and negative charges together. So that's why they are neutral. See, when you bring a positive charge and keep contact with this positive rod, positive charge rod, and bring in contact with this top, what will happen? The neutral atom, from the neutral atom, the electrons will
The number of positive
go.
charges is the
Okay.
same in both, sir.
Yes, yes. See here, electrons will go to here in the rod, and number of positive charges will increase again. Okay, you are correct, Priyadarshini. Number of positive charges will be increasing. What will happen? Number of positive charges will be increasing. So then what will happen? So this will diverge again more. Okay, they will repel each other very strongly again, much greater than earlier. So you will see, if this was maybe some 2 centimeter, now you will see the divergence is some 6 centimeter. Okay, So more positive charges will be induced in the gold leaf. Okay, or gold leaf will be charged with more positive charges. Understand? Because from the neutral atom of the gold leaf, the negative charges will go to that rod. Okay, these will go to this rod, leaving the positive charges over here, leaving the positive charges over here in the leaf. Okay, and since there will be more positive charges, they will be repelling more strongly. Okay, so this is how you can understand, because you have brought a positive charge over here. If it is actually uh, positively charged, then they will be repelling each other very strongly. But suppose this this is uh, negatively charged. Suppose this is negatively charged. Now you bring a positively charged rod. What will happen? What will happen? Can you tell me, Priyadarshini, Nikhil? Can you tell me what will happen? So these negative charges will go here and make it neutral, right? This rod will be neutral after some time. Okay, maybe if two charges, electronic
Gold leaf
charges are going
becomes positive, sir.
2 to 4. So here suppose there are, yes. So this will be neutral then, right? The gold leaf will become neutral and they will come near each other. Okay, they will come near each other. So this divergence you will not see if you bring the positive charges, because the negative charges will go to the rod and that rod will be neutral after some time, and you will see the gold leaf when they were in the diverged condition, or they were repelling each other very strongly, they will come near to each other. Okay, so this is how we can understand what we can understand that uh, the rod you have brought here, whether it is positively charged or negatively charged. This is the way we can find out the polarity. Okay, so to find out the polarity, you have to take a charged uh, electroscope, okay, or the gold leaf. Okay, this is how you can find out the polarity. Now look, I can tell you one more thing. Suppose I think I have not told you regarding earthing. Suppose this electroscope is charged by a positively charged rod. Okay, so there will be also positive here. Okay, now suppose this rod has been just taken away, so still it will be retaining its charge for some time. Now during that time you just remove this rod, still it will maintain its positive charge for some time. Now if you immediately touch it, what will happen? Touching means what? Touching means earthing. If you
What things?
do this thing, so what will happen? So what will happen then? What will happen? Negative charges will go
Gold
from the
leaves
earth.
become neutral, sir.
Yes, and they will, what will happen? What will, just tell me?
Gold leaf becomes
They will
neutral,
become
sir.
neutral. They will become neutral, right? And they will come to each other. They will become neutral and they will come to each other. Okay, they will not repel. Okay, see, this is the repulsion, but now they have come to normal state. This will be neutral. Understand? Because see, if you touch, even if you touch, this will happen. Touching means what? See, we are connected to the earth, and earth is actually a sea of charges. Sea of what? Sea of charges. Okay, so when you touch it, the electroscope directly will be arced. That means the negative charges will go through your hand to this gold leaf, and see, negative and positive, they will cancel each other or make them neutral. So finally gold leaf will come to its neutral position. Okay, they will no longer repel each other. So understand? Okay, I hope you understand. So I'll go to the next part. So now charging by induction. So in the charging by conduction, what we have seen, we have to touch it. See, we have to touch it. Okay, and when we touch it, what happens? The polarity of the induced charge. Okay, polarity of the induced charge, not induced, I should say, polarity of the charge which we get due to conduction is the same in nature. See, I have brought the positively charged rod. I have got what charge? Positive charge. Okay, I have got positive charge on the gold leaf. So by conduction, we get same kind of charge. Same kind of charge will be obtained. Charges will be obtained by conduction. Okay, but we'll see shortly that when we do induction, charging by induction. So induction means don't touch directly. Don't touch the sphere directly. You bring near. Okay, very near to it. Near to it. Okay, so very near to it. Then what will happen if you bring very near? Then see if it is charged. So we'll see here. So and we'll see in induction the opposite charge will be induced to the body. Okay, induced to the sphere. Now look here. Now the situation is I have see in the A situation is and this figure has been taken from your book. So now learn here carefully so that you can understand better, and while reading you will understand again better. Okay. So suppose I have taken two identical metallic sphere A and B, and both are neutral now, and both are made to help with insulator. These are insulator actually, insulator. Okay, insulator. Okay, I'll just yeah. These are actually insulator, insulating stand. That means what? In why do we use insulating stand over here? Can you tell me?
Because the charge from the sphere should not enter into the earth.
Earth. It should not go into the earth. Okay, so that is the reason. Okay, now look, I just bring them in contact. So A, B are in contact. Look here. So A, B are in contact. Now if I bring one positively charged glass rod, so this is a glass rod, positively charged glass rod, near to the surface or the sphere of A. Say near to the A I have brought. Now as I said, by induction you can have you can charge the body with negative with oppositely charged. Okay, if you have positive rod, then you can induce charge, negative charge you can induce. So how I'll tell you, see, if I have positive charge here and brought near to the sphere A, metallic sphere A, what will happen? See, this positive charge, see here actually neutral means what? Neutral means you have both the types of charges nearby. Okay, both charges are there, positive and negative together. They are there together. Here also positive and negative, they are together. Positive and negative together. That's why they are neutral. Now when you bring a positive charge, positively charged rod, what will happen? These positive charges will be actually repelled and repelled. Okay, and negative charges will be attracted towards it. Okay, it will be attracted towards the sphere A. Okay, the left surface of the sphere A, and positive charges will be repelled by this positively charged rod. That's why the positive charges will go to the other end. That means the rear surface of the B. So that's why you can see the negative charges are there in the left surface of A, and in the rear surface of B you get positive charges because positive charges will be repelled. Now, so this will happen until there is an equilibrium situation. Equilibrium situation means what? See, when positive charges are here, negative charges are here. So more negative charges will try to come over here because of the attraction of this positively charged rod. But see, already some negative charges are sitting over here. They will repel. So the attraction and repulsion, this will when they will come into a like equilibrium situation, then what will happen? you will see this situation. Okay, now if you remove this rod, what would have happened? Again, they would be neutral. Okay, if you immediately remove this positively charged glass rod, they will come to their previous situation. This situation, they will come to this situation. Okay, they'll be again neutral. But I'm not doing that here. So what I'm doing is, at this situation, I'm just making a gap between A and B, a little gap between A and B. What I'm doing, I'm just making a little gap between A and B. So at this situation, what will happen? Still, the effect of this positively charged rod will be there. That's why, see, the left surface of the A will be having excess of positive negative charges, and the rear surface of the B will be having again excess of positive charges. Okay, this situation will maintain because of the presence of this positively charged glass rod. Yeah. Now, if suppose I remove the glass rod, what will happen? What will happen? Because see, these positive charges were there, and there was negative charges. Then what will happen? They cannot go from one to another because they have a separation now. Now they are having certain separation. They are not in contact. So the positive charges and negative charges, they will not come close and combine to make it neutral. Rather, what will happen? They will attract each other such that their like surface in between. See, nearer surface will be having charges rather than the rear surfaces. This is rear surface of A. This is rear surface of B. So they will not have any excess charges, but the surface like near to each other will be having, say, A will be having positive charge and B will be having, sorry, A will be having negative charge and B will be positive charge. Why they have come? See, negative charges have come here because of the attraction by these positive charges. Okay, this is a mutual attraction between positive and negative charges. They are, because of that, they are coming near to each other, but they cannot come to a point and make them neutral because they are not in the same body. They are a different body now, A and B. That's why they cannot come close and make neutral or cancel each other. So now if I increase the gap between this A and B, what I will see, the effect of this positive charge will be very less on this. The effect of the sphere B will not be there on the A, or neither the effect of A will be there on the sphere B. So for that case, what will happen? Whatever charges were there, okay, positive charges were there. So these positive charges will be equally distributed, okay, equally distributed over the surface, whole surface. See, over the surface it is equally distributed. And similarly, the negative charges also in the A, like, will be equally distributed on the surface of the sphere A. Okay, so this is how they will be. See, one will be getting positively charged and negatively charged, which was actually near to the glass rod, and the sphere which was away from, little bit away from the glass rod, will be positively charged. So this is charging by induction. This is charging by induction. Okay, do you understand? Is there any issue with this? I hope no. Nikhil, are you there? I don't know whether, I'm not able to see whether you are there or not. Is Nikhil there?
Yes, sir.
Okay, nice. Okay, so is it understandable for you?
Yes, sir.
Then I'll proceed to the next part. Okay, then I'll proceed to the next part. See, yeah. Okay, so see, I was doing induction, like charging by induction. Now, if uh, I do a simple experiment again, like, see, I am having a neutral sphere. Initially, I have a neutral sphere and it is mounted on a So this was supposed initially a neutral sphere and mounted with an insulating stand. Okay, here. Now if you bring this negatively charged rod, so what will happen? So this surface will be having positively charged, like positive charges, excess charges will be there, positive charges because of the attraction by negative charges. Okay, and this surface will be negatively charged. Now look at this situation. If we arc this side, okay, the right hand side which is shown over here, so what will happen? The negative charges will go into the arc. So what you see, this surface will be having no charges over here if it is arced already, and here you will have positive charges. Okay, excess positive charges. Now at this situation, if I just remove the rod, remove the rod, okay, then what will happen? If I remove the rod, then what will happen? At this situation, if I remove the rod, see, at up to this my rod is there. Now I am just removing the rod. I am removing the rod and it is still arched. What will happen? Can you tell me? Still it is arched. What will be the next situation here?
It becomes neutral, sir.
Becomes, yeah,
Neutral.
it will become neutral because positive charge, see, negative charges will come here and it will make negative, right? So negative, sorry, neutral. Negative charges will come from the R, okay, and they will make neutral, okay. They will make neutral. So you will get a neutral sphere as it was earlier. But see, now I'm taking a different situation. See, it is charged as I told. So now it is arc means what? This surface's negative charges has gone to the arc. Okay, it has gone to the arc. Now at this situation, what I'll do, I'll just remove the arc first. Okay, arcing first, and then I'll immediately remove the negatively charged rod. What will happen? These positive charges will no longer go to the earth because earth I have removed before I remove this negatively charged rod, right? So it will have excess positive charge, and you will see that positive charge will be distributed all over the surface of the sphere. I hope it is understandable, right? Is it
Yes, sir.
understandable, Nikhil? Nikhil, what do you say? You understand? Do you
Yes,
understand
sir.
this? Because yeah, these are the questions you will get in your exam actually. In your exam paper, this type of question will come. When we ask what happens if we remove the rod after bringing for some time, after keeping some time, and just bringing like removing the rod, what will happen? If I ask, if I touch it, what will happen? So these are the kind of question you will see in your exam. Okay, so I'll just show you. Uh, I'll just show you in your textbook. All these things are there. Okay, I'll just show you in your textbook. Yeah. So see, the whole thing is here in your book, whatever I have discussed. But electroscope, like how to measure the polarity, that part is not there. Okay, how to know the polarity, that part is not there. Okay, so I hope you will be able to answer that kind of question also, as I have discussed. So this charging by induction I have discussed thoroughly. So there will be few questions over here in the example part. I think this also I have discussed somewhat. You can read again from your textbook, and then you tell me if you are like encountering some question which you are not able to answer regarding this topic, then I'll take up again. Okay, so far my voice was clear, right? Was there any problem? Actually, I
No,
have a
sir.
small kid.
Was
I'm sorry, actually. Yeah, yeah. I have a small kid, so sometimes he makes some noises. I hope it doesn't disturb you. Does it?
No, sir.
Okay, nice. So see now we have learned there are two types of charges, positive and negative charges. Like two types of charges in the sense polarity of the charges are two, as a positive and negative, and we have learned how to make a body electrified or charged, that is by conduction or induction, and now we have learned how to find out or how to know whether any body is positively charged or negatively charged. That can be done by Gottlieb electroscope. And here in your textbook also it is written like uh, one activity was given by which you can use the aluminum foil and make uh, your own homemade and handmade electroscope and do the same experiment. So if you are so interested, you can just do it. Now what I'll do today, we'll learn another part of this charges, that is the basic properties of electric charge. There are few properties, like see, uh, I'll just go here in my presentation. Yeah. So additivity of charges. See, the charges are, they have positive polarity, negative polarity. So can you tell me, Nikhil, uh, if you are here, can you tell me whether uh, these charges are scalar quantities or uh, vector quantities? Can you tell me? Is there any idea whether they are positive scalar quantity or vector quantity? Scalar or vector? Priyadarshini?
Scalar, sir.
Nice. They are scalars. Even though they have polarities, different polarities, negative and positive, but they have only magnitude. They don't have any direction. Either negative magnitude or positive magnitude. Okay, but they don't have direction. That's why they are actually uh, called scalar, not vector. Okay. Now, uh, additivity means how do we add them? So like the scalars will be added. The scalars are simply some number, either positive number, so maybe 3, maybe another 2, or maybe another some 9, kind of this is some numbers, right? Either positive or negative, that doesn't matter. So charges are like this. So how do we add the number? Simple algebra, right? Simple algebra. If I add 5 and 2, two positive numbers, so I'll write 7. Similarly, if I have 5 charges, 5, we'll see the units and all just after that. So if I have 5 charges, 5 positive charges and 3 negative charges, then I have to actually add them with proper sign. I have to add them with proper sign. So then, see, earlier you people have asked me, sir, why you are getting net charge? So it was negative and this was positive. So how I got net charge -1? So this is the answer for
Plus
that.
2,
Okay.
sir.
So these are yeah, these are simply scalar number. Okay. But when you are adding, no, then you have to take proper sign. If I have negative charge, you have to take negative. If you have positive charge, so in this case, what will be the addition? What will be the result for this?
Plus 2.
This will plus 2, right? You'll get positive 2, right? If I say uh, plus 5, then plus 3 minus 2. So what will be the result? Simple
Plus
algebra. So
6.
this is your first standard algebra. Okay, this will be 6, right? positive 6, but you have to tell me
Sir.
whether it is positive or negative. That is the thing. So additivity, so these are scalar numbers, but they have polarity, certain polarity, positive or negative. When you are going to add them using simple algebra, you have to consider the sign of the charges or polarity of the charges. Okay, just a minute. Just 1 minute. So this is about additivity of the charges. So I hope there is no doubt, right? Now we'll see conservation of charges. See, during the uh, induction or like conduction process, we have seen, suppose you have a power, okay, and you are just rubbing a rod, glass rod or ebonite rod, suppose, okay, sorry, ebonite rod with it, okay. So you'll see after rubbing what will happen. See, first in the beginning, when you take both of them were actually neutral. Both of them were neutral now. Now after rubbing, what will happen? After rubbing, this rod will be negatively charged. Okay, and the part will be having positive charges. Okay, over here. Okay, positive charges over here. So how is it happening actually? I have told you, now again I am telling you this thing. I'm just repeating it. What happens when you rub both of them? See, no new charges are appearing into it. Okay, no new charges are appearing. Already they have positive and negative charges. That's why they are neutral. Okay, they have charges, but they cancel each other. Positive and negative charges cancel each other. But when you rub it, what happens? Positive charges go into the part, and same amount of negative charges are coming into the ebonite. That's how, if there are 4 charges over here, positive charges over here, same 4 negative charges will be coming here. So it will be 4 negative, and here this will be 4 positive. That means there is just transfer of charges. But is there any new charges creating over here? Are we creating by rubbing? No, we are not creating. Neither we are destroying any negative charges over here, or neither we are destroying any positive charges over here. What happens? Just transfer from one polarity to another polarity, like one place to another place. So this is how the charging is happening. Okay, and this is why the conservation of charges is coming. That means the total charge will remain conserved. Okay, remain conserved. Okay, will remain conserved. We can see, that means what, we can neither create charges nor destroy any charge. Just there will be a transfer of charges. See, here you might be thinking, sir, you are saying that charge number of charges are conserved. Okay, but here I can see some negative charges and here some positive charges. So how you are saying that it is conserved? Conserved means the total charge before rubbing and after rubbing will be equal. Okay, these two will be equal. So total charges before rubbing and after rubbing, sorry, after rubbing should be equal. So how is it equal? See, before rubbing, what was what was the total charge? What was the number of charges? See, both were neutral, so total charge was zero. Before rubbing, there was zero. Now after rubbing, there are some negative charge, some positive charge. See, if you just bring them together, if you just add this positive, this positive, and this negative, so what will happen? They will make neutral to each other. So again, this will be total charge. See, total charge is zero actually. So what is the total charge? If you just add them, it will be zero. So there is no new charges are created here. Okay, no new charges created. Okay, neither negative charges or positive charges are destroyed. So the conservation law says that the total charges will be always conserved. Total charges remain conserved, and charges cannot be destroyed or cannot be created. That is the thing. Okay. So this is all about conservation of charges. You will see in your textbook it is written very elaborately. Now we'll learn another point, quantization. So the conservation of charges, here we see conservation of charges, but there are many physical entities like momentum, linear momentum, which you might have learnt in your 11th standard, which is denoted by P, total energy, okay, angular angular momentum, which is denoted by L. So some physical phenomena where linear momentum will be conserved, somewhere total energy will be conserved, total mechanical energy conserved, and some places you will see angular momentum will be conserved, and some places all three will be conserved. So there are many physical quantities in physics, and time to time we will see that one or the other quantity remain conserved. Okay, so conservation law is very common for physics. Now we'll see quantization of charge. So quantization means what? Quantization means, see, according to like experimentally it is proved that any amount of charge, suppose q amount of charge is there. Okay, I'll just go with your textbook notation. Q amount of charge is there. It is proved experimentally that this amount of charge can be expressed as integral multiple of some basic unit of charge, and that basic unit of charge has been taken as E. E means the magnitude of, so E has actually the magnitude of charge 1.6 into 10 to the minus 19. Okay, actually this is the charge of electron or maybe proton, you can say. Okay, magnitude of the charge of proton or uh, electron. Okay, by convention electron has been taken negative and proton has been taken positive. Okay, so what is quantization of charges? So any amount of charge can be, any charge can be expressed in terms of integral multiple. This is integer actually, integral multiple of uh, a fundamental or basic unit of charge, which is 1.6 into 10 to the power minus 19, and that is denoted by small e. Okay, so you can see that any amount of charge can be expressed in terms of this integral multiple of this basic unit of charge, and this integer can be, this is an integer, n is integer, it can be positive number, it can be even negative number also. That is what I mentioned in your book. Now look, see, from here what I can say, I can say that, see, charge can be expressed, or quantization means what? You can just count it as a discrete number. If this much, suppose this is charge, total charge Q. So you can name it, how many electrons or how many E are there. Maybe some 10 to the power 18E, or some maybe 10 to the power 10E, 10 number of E's are there. So this is how we can quantify how many charges are there in that. Okay, so this is actually quantization. Now if I say I have 1 coulomb charge, 1 coulomb charge, can you tell me how many of E are there or how many of electrons are there? Okay, electrons or protons are there? Can you tell me? See, E has value this minus 19 coulomb. Okay, the SI unit of charge is coulomb. Okay, SI unit of charge is coulomb. Okay, coulomb, and it is denoted by capital C. Okay, coulomb. So if I have 1 coulomb charge, so can you tell me how many electrons are there in that? Or I will say negative in that case. Negative 1 coulomb charge is there. So can you tell me how many electrons are there here? So I'll just apply this quantization. Q is equal to N into E. Okay, I'll take it here minus because E is minus over here. So N will be how many electron, number of electrons will be there, Q by, so this is minus Q already given, and this is minus E, minus goes off. So this is 1 coulomb, and this is actually 1.6 into 10 to the power minus 19 coulomb. So it will be something like of the order of 10 to the power 18 electrons will be there here. Okay, this is how. So there will be many questions in your exam also. Okay, are you still there? I think you people are there, right? Both of you are there,
Yes.
right?
Yes, sir.
Okay, nice. Okay, so I'll just take up 1 or 2 examples from your textbook, then I'll stop the class. Okay, so look here. So this additivity, these are the properties, basic properties of the charges. You read from your book, you will understand again. If you get new points which I have not mentioned, you can tell me again. Okay, I hope I have covered all these things. See, yeah, see here. See, 10 to the power minus, 10 to the power 9 electrons are there. I'm sorry, you can read it. So if 10 to the power 9 electrons move out of a body, another body, move out of a body to another body every second, how much time it required to get a total charge 1 coulomb? Can you do this without seeing the answer? Can you guys do it and tell me what will be the answer? Priyadarshini and Nikhil, both of you, can you tell me? See, if the 10 to the power 9
Yes.
electrons, uh, yeah, just do it and then tell me. Then we'll stop the class with this.
1.6 into 10 power minus 10, sir.
So the question was how much time is required? Okay, how much time is required? Okay, let us see what is your answer. What is your answer? The answer will be
1.6 into 10 power 10. For Q
1.6 into,
sir.
no, I didn't get it.
Power 10.
10, okay, no, this is the answer actually. You see, this is the answer. 6.25 into 10 to the power 9 second it will take. Okay. Okay, so you guys, what you should do is you just read these examples. Okay, after reading the text, you should read the examples and then try to understand and solve if you can. Okay, I think we will stop the class here today. The next day we'll take up from here Coulomb's law and all. Okay, and you guys can see some previous questions up to what we have studied so far, or what we have learned so far. Okay, so next class will be on Wednesday. So on that day we'll take up from here Coulomb's law and many other interesting things we will learn here. Okay, so with this we'll stop today's class. Is that all right, Priyadarshini, Nikhil?
Yes, sir.
So, okay, sir. Thank you, sir.
Okay, okay then. Yeah. Okay then. Yeah.